Everyone, this is Professor Oaks, and this video is about simplifying rational expressions. So, the simplest type of rational expression that we might be asked to simplify is a fraction, like 30 over 42, right? So, if I want to simplify 30 over 42, I need to figure out what the greatest common factor is between the the 30 and the 42, and that ends up being 6 because 30 is 5 times 6 and 42 is 7 times 6. So I see that 6 is the largest number that goes into both the 30 and 42 evenly, meaning without a remainder. So if I divide 30 by 6, I get 5, and if I divide 42 by 6, I get 7. So it's 5/7. Alright, so let's try another one. We have 32x plus 80 over 8. Now, remember that I want to figure out the GCF of the numerator and the denominator. So if I look at the GCF of 32x plus 80 and 8, right? So 32x plus 80, that would be, all right, I have to figure out what the greatest common factor is. Well, that's going to be 8 times 4x plus 10. And then for the 8, I just know that is 8 times 1. So I see that 8 is the largest number that goes into the numerator and denominator evenly. So I am going to rewrite this as 8 times 4x plus 10 over 8 times 1. So the 8's divide out just like this. So that will end up being 4x plus 10. So there we go. Alright, so let's try another one here. So simplify the expression. Here we have 15x minus 9 over 5x minus 3. So remember, I want the GCF of 15x minus 9 and 5x minus 3. So 15x minus 9, that will be 3 times 5x minus 3. And 5x minus 3, well, that's 1 times 5x minus 3. So I see that the greatest common factor is 5x minus 3. So this will be 3 times 5x minus 3 over 1 times 5x minus 3. I divide out the 5x minus 3, so I have 3 over 1, or just 3. Alright, let's try another one. I have 63x to the 5th over 49x to the 6th. So I need the GCF of 63x to the 5th and 49x to the 6th. So 63x to the 5th, well, what is that going to be? That's going to be, now think about how I'm going to write this out. All right, I know that 63 is 7 times 9, all right, times, well, x x because there's x to the 5th, right? And 49 x to the 6 is 7 times 7 times x times x times x times x times x times x times x, because there's 6 of them. So the GCF is going to be 7x to the 5th. So what do I have? I have, well, 9 times 7x to the 5th over 7x times 7x to the 5th. So the 7x to the 5ths divide out, so I'm left with 9 over 7x. So I hope that you're really enjoying this right now. But remember, all we're trying to do is divide out the GCF from the numerator and the denominator of each of these rational expressions. So let's try again. Alright, so I need the GCF of 18c squared d minus 6cd squared and 6cd. Alright, so 18c squared d minus 6cd squared. Well, that looks to me like it is 6cd times 3c minus d. And then 6cd, the denominator is 6cd times 1. So this ends up being this rational expression 6cd times 3c minus d over 6cd times 1. So 6cd divides out. So I have 3c minus d over 1, or just 3c minus d. There you go. Alright, so let's try another one. So we have x to the 5th plus x to the 6th over x to the 4th plus x to the 5th. So let's find the GCF of the numerator and the denominator. So x to the 5th plus x to the 6th is x to the 5th times x plus 1, or 1 plus x. It doesn't really matter how you write that, because x to the 6th plus x to the 5th is x plus 1, alright? And then x to the 4th plus x to the 5th, remember that's also x to the 5th plus x to the 4th, right? So I could rewrite that as just x to the 4th times x plus 1. So then again, I could write out 5 x's and 4 x's, but if I just look at it as it is, it's x to the 5th times x plus 1 over x to the 4th times x plus 1. The x plus 1's divide out, and then x to the 5th over x to the 4th. That's x to the 5 minus 4. Remember the exponent rules we may have talked about before. That's just x to the first power, just x. So if you didn't want to write out the 5 x's and the 4 x's like I did before, and then divide out the common factors of x, then you could just use the exponent rules. But the answer is x here. Alright, let's try another one. We have x squared minus 8x plus 16 over x squared minus 16. So here we really need to remember our factoring skills from the previous chapters, because we're going to factor each of these numbers, or each of these expressions, alright, here. So x squared minus 8x plus 16, that is going to be, well, that's x minus 4 times x minus 4. And x squared minus 16 is x plus 4 times x minus 4. So we see the GCF is x minus 4. So really, right? I've been rewriting these the whole time, but now I hope that you see it's a bit much to rewrite these, right? So if I divide out the common factor, I already can see I'm left with x minus 4 over x plus 4, and that is my final answer here. Alright, so just as a side note, you notice I never just cancel the x squares, or I didn't cancel the 16s, right? I only can cancel out the greatest common factor. So if you don't factor the numerator and denominator first, you cannot do these types of problems here. Alright, so, well, you could do them, it just would be wrong. Alright, so the GCF of x squared minus 4x minus 12 and x plus 2. So x squared minus 4x minus 12, that will be, alright, that will be x minus 6, x plus 2. And x plus 2 is just 1 times x plus 2. So I see that the GCF is x plus 2, so that divides out. So I'm left with x minus 6 over 1, or just x minus 6. What a time to be alive, right? Let's try another one here. Alright, so we have x squared y to the third plus x squared y squared, and x squared y squared minus x squared y cubed. So the GCF of x squared y cubed plus x squared y squared is x squared y squared. So this is x squared y squared times y plus 1. And x squared y squared minus x squared y cubed is going to be x squared y squared times 1 minus y. So the GCF is x squared y squared. So I can divide this out, and I'm left with y plus 1 over 1 minus y, or the y plus 1 can be rewritten as 1 plus y. So my final result is 1 plus y over 1 minus y. Alright, what a time to be alive. So let's do another one here. I have a negative 20 minus x plus x squared and a x squared minus 8x plus 15. I'm going to write this first expression in descending order so that it's x squared minus x minus 20, so that it's a little bit easier for me to factor and then find the GCF. So the GCF of x squared minus x minus 20, well, I don't have a GCF, I can factor this, right? So what do I have? I have x minus 5, x plus 4, then the denominator x squared minus 8x plus 15. This is x, right, minus 5, x minus 3. Then I see the GCF as x minus 5, and then I am left with x plus 4 over x minus 3, or the x plus 4 can be rewritten as 4 plus x. So then I see that I match the solution over here, 4 plus x over x minus 3. What a time to be alive. So now we have one last example today in this video. That's all that I have for you. I wish I had more. I could do this all day, right? I could do a challenge of simplifying 1,000 rational expressions in less than 24 hours. Who would want to see that, right? So now here we have a numerator of x minus 8 and a denominator of x squared minus 16x plus 64. So the GCF of these, well, x minus 8 is just 1 times x minus 8, and x squared minus 16x plus 64, that ends up being x minus 8 times x minus 8. Then when I look at this, my greatest common factor is x minus 8, so I divide that out, and I'm left with 1 over x minus 8. What a time to be alive. That's all I have for you today on simplifying rational expressions. I hope that you enjoyed this video and that you're already looking forward to the next one. Thank you and have a great day.